So for the past couple months, we have been working together with Sanoma in creating Vaalikone and voting advice applications, parliamentary elections, and then all the upcoming elections like Euro elections. The project consisted of 3 parts. So in the first part, we made a kind of private admin UI and an UI for the candidates to answer the questions. And then in the second part, we made the public site where anyone could go in and answer the same questions and then compare or get recommendations based on the way you answered and the candidates answered. And then the third part of the project was the result service. So on the election night, we had widgets that displayed the results of the election. And initially, the team consisted of 4 developers, two from Sanoma and 2 from Futurice, and 1 designer from Sanoma. But then after the first part of the project, which was we were actually going to reuse the old implementation, but we found out that we actually had to rewrite it completely. So we were already behind the schedule at that point. So we added a few more people to the project. I joined the project, and then towards the end of the project, we found out that we were even more behind the schedule, and there was a hard deadline, of course, because of the election day. So we added Ville and Mikko, and Antti was also helping with the project towards the end.
All right, so a couple of words about the Vaalikone or election voting advice application. That is something I found from Wikipedia originally, I think. I think these kind of voting advice applications are pretty much like Nordic things, because I couldn't find any like English language resources much about those, and that's why it was a bit difficult to like translate it in the first place. I guess also in Germany there are some of those. I can't remember what they called them, but something similar. But yeah, it's apparently only big thing in Finland and other Nordic countries. And yeah, some of you might be very like familiar with the Vaalikone things, but if not, let's go through a little bit about our implementation. So basically, everything starts with selecting your district, because how the elections are organized in Finland, like these governmental elections, you need to select the district you are allowed to vote in before you can do anything else. Then you get the answer to the questions. There is this range of 5 options from totally disagree to totally agree, and there were like 30 questions in Helsingin Sanomat side and 35 at Ilta-Sanomat side. And after answering the questions, you get to leave some basic information or background information about yourself. This is like totally voluntary, and it is only used for some statistical purposes, and you can leave everything empty if you wish. After that, you get the actual results or the recommendations, which consist of the because of the voting system or the election system in Finland, there is quite a much of weight of the actual party side of the candidates. So the first like recommendation is actually from the best suited parties, best suited candidate, instead of best candidate from all the parties. And that well, it's had some challenges to communicate that to the users, so there was some additional text and stuff, and lots of Twitter communication and that kind of things. About the candidate, like the general match percentage, and then some match percentage by some categories, such as welfare, world, climate, and such. And then some highlight of the one of the questions that you had the biggest difference between you and the candidate. Then you can see the more detailed information about the candidate, which consists like their own description they have written, and optionally, and all the answers to all the questions, and maybe some explanations to the answers if they have written some. Then there are these possibility to see all the matches, like list of all candidates and see what is the best match regardless of the party candidate is in, and then you can filter the results by those few categories. Then there was this value map kind of thing that shows the parties in this map that is like left and right side is this left wing, right wing axis, and then the y-axis is this conservative and liberal axis, and then there's this additional green halo thing. I don't know if you can see it from the picture, but there is this green thingy over the dots, so that is representing the green values of that party. And then you can see your own spot there, which is calculated based on your answers. And there you can compare or see how liberal, left or right wing you are compared to the other parties. Alright, then a few words about the algorithm. Basically how this matching works is that, or it used to work like that, so that we calculate average answer for a party based on the candidates of the party, and then calculate the difference from your answers to that party's answer, and then that's how you pick the best suited party, and after that you pick the best candidate inside of that party for yourself. We actually had some decision that Esa Mäkinen decided that we will publish an article about this, how this algorithm is working, and there's actually a screenshot of the code in that article. And
because there was a lot of criticism,
yes,
in Twitter especially.
Yeah, there was this people were thinking that it is recommending wrong people to them and that kind of things that you would expect, obviously. And then there was this article about how this is actually working and why is that reason that these recommendations are what they are. And this caused even more discussion in Twitter sphere and everywhere else. So we decided to change the algorithm a little bit. So the new renewed algorithm is actually using median instead of average, which helps a little bit the issues what was discussed, which was mainly the previous algorithm was I think it was a little bit biased towards the small parties, because the smaller the party is, then the answers of the candidates are more unanimous than in bigger parties, and that caused them to gain a little bit of advantage. But the median approach should help a little bit with that. But yeah, and then there was this other article about the renewed algorithm, and I think we got a lot of good feedback to be transparent about the algorithm. Lots of people and other news sources such as YLE.
So that was the second part of the project, and then in the last part we started creating widgets to display the results. So this is just a selection, 5 of the actual widgets. We had maybe 10 different widgets that display the election results in a nice way, visualizes them and shows you which parties won and stuff like that. And we had pages for different parties and different areas and different districts. And then these widgets, some of them could be embedded on the newspaper website. So here's a screenshot of the actual election day. They were added both on the topmost news on Helsingin Sanomat and Ilta-Sanomat. So everyone who visited those pages caused traffic to our service, which is important, and we will come back to that later. So then about the tech.
Yeah, there were a couple of our few principles that we were thinking about when designing the architecture and the tech or other tech choices we used in that project. So first of all, it was and especially with the result service, that the widgets needed to be embeddable to the news sites and articles. So we had to take that into consideration. we needed to be able to handle the load, and this actual service is like like quite unique in that sense that before the actual election evening, the traffic and the request sizes, they are quite moderate and stable, but during the night it peaks like 100 times or something like that, like crazy peak for a couple of hours when the results are actually published, and then it dies down and stays dead pretty much. So it is just this really short time that it needs to handle the load. Then it needs to obviously have high performance because people want to see the updated results as fast as possible. Then there were some other things like not running in the domain root, just like this technical stuff, because there are like many election machines running in the same Vaalikone.fi domain, and we had this new version Eduskunta 2019, and the old versions were still there, so that needed to be figured out a little bit differently than usually. Then the schedule was pretty tight, and the deadline was quite hard, so the election day was when the elections day was, so we had to get the stuff done before that. There was no like way of postponing that, so that's that. Then there was some like they already mentioned, the speed of publishing the results, but there is also this other angle that results can be published at 8 o'clock in the election night, and we actually got the pre-vote results before that, but we are not allowed to publish that. But
5 minutes before.
Yeah, but we wanted to be fast as possible to publish those results right after the allowed time. Then there was a couple of other things like archivability. Because the nature of the election results are that they will accumulate in the election night and then they stay static after that. So we wanted it to be like static pages after the election day. So that was one thing we needed to think about. And then the reusability, obviously, especially this year, that when we had the Euro elections right after the governmental elections or parliament elections, so we needed to be able to reuse that same code base for the Euro elections as well. And obviously the maintainability should be thought after as well.
So then about the tech choices that we made for this project, and so we rewrote the backend. So we decided to use Scala and Play framework because we have been using it in other projects as well at Sanoma, but we reused the old database, so we remained using MySQL for the database. And then the front end, because of the tight schedule, we wanted to use a familiar tech stack there as well. So we decided to use React and MobX, but instead of React, we used Preact because we wanted to get as good performance as possible, and it's tiny for widgets. It's really nice. And we actually had to use MobX 4 because of browser support issues with the MobX 5. And then additional libraries that we used in this project. One of them is IOTS, which was really nice. It's a library. There was actually a presentation about that earlier by Axel. So it's a library that provides you runtime type checking in TypeScript, because TypeScript is only for compile time, but then you can do some runtime validations as well. Then we wanted to reuse some custom select boxes that we had done in another project at Sanoma. So that's why we wanted to use React Select. And in order to do that, we had to use Preact Combat in order to use a React library in Preact. And it didn't work out right out of the box. We had to patch it a bit. And for that, patch package is a really nice solution that you can patch your node modules. It's really nice. And then for styling, we wanted to use CSS custom properties, but because of browser support, we couldn't actually use them, so we used post CSS variables that actually, for the syntax, they are like CSS variables, but then in build time, it actually replaces them with the actual values. And for testing, we use Jest, React testing library. And then for formatting and linting, of course, Prettier, TSLint, and Husky for adding Git hooks to check those formatting and linting.
Yeah, then a few words about the MobX or state handling. We have been using the MobX for a few other projects in Sanoma as well, and have been found that it is pretty nice. And yeah, basically it implements this observable pattern, which makes quite easy to like have the components react to the store changes in the stores, and also optimize the rendering, because then the components, small components, can react only to like small parts of the changes in the store. Then, and it's quite small boilerplate, so it's quite fast to write. For example, this case when we had like multiple self-contained widgets that should handle their own data and state, so it was easy to write their stores separately without having to write any like lots of boilerplate for that. Yeah, there are some basic things. I don't know, probably most of you are at least somewhat know the basics of MobX, but pretty much the thing is that you can create stores with observable or like fields, and then mutate those with actions, and then to actually subscribe to those stores you just have to like annotate the component as observer and then reference that field inside of the component, so then it will react automatically to changes of that, which is pretty simple and straightforward, but it might seem a little bit like magical at first, but if you start using it and read the like documentation, then it's quite clear.
Then a pretty annoying thing in pretty many UI designs and implementations is this case where you model your data and loading status of data in a Boolean. Then things like this can happen. For example, because now we don't have inbox anymore, I'm forced to use Gmail, and just for fun, I was checking whether I have spam in my work email account, and yay, I don't have spam. But it's just a bug in the UI, because they probably have a state that says that, okay, the UI is not loading the data, then let's display the data we have. But the truth is the fetch has not happened yet. So never model your data or loading of data with Booleans. And there's a really nice solution to this in Elm, but it's not possible out of the box to do that in TypeScript because of the typings. But there's a really nice solution to that as well, and there's a nice talk about this by Chris Jenkins from Oslo Elm Day, and then there's a nice blog post about that as well. And how we did this, we reused the idea of RemoteData. So instead of having just a list of, for example, list of data and then a flag that says is loading Boolean, we have the data is of type RemoteData, and it can be in 4 different states. So it can be in state not asked before the fetch happens, and then it can be loading if the fetch is ongoing, and then it can be either success or error. This is how we have a render component for this RemoteData wrapper, which is basically a switch case for this, and based on the status, it then renders either a placeholder that says, okay, there's no data, has not been fetched yet or something, and then if it's loading, then let's display a spinner, and then if there's an error, let's display an error, and only if it was successful, then let's display the data. Using this, we can then avoid rendering a inconsistent UI. And this is how we use it then. We just wrap the stuff that needs to be fetched in a RemoteData wrapper, and it will render correctly based on the status of the data.
Yeah, then a little bit about the architecture and the things we had to take into consideration here. The most important parts here are probably on the upper side of the diagram, there's this lambda pollers and S3 bucket. So what we did was that because of the high load we were expecting, we actually protected our app by saving our API to the S3 bucket with some lambdas. So pretty much we just created a static JSON files out of our API endpoints and served them from the S3, which can take like almost infinite amounts of load. So we pretty much didn't get that much of a load to our actual servers, but instead all of the hits were to the CloudFront and to the S3. And that worked really well. That was like, we tried this for the first time in our project, so that was a little bit experimental. So that's why we had also the fallback option to use the our own application servers to serve the API if something went wrong with the S3 buckets. But it worked really well, and the update rate of the S3 is super fast. You get like almost no like additional like latency from updating stuff to S3 and serving it from there. Then the other interesting part in our case is this NDA zone you can see on the right, which consists of the integration server that fetches data from the Ministry of Justice, and that is like before 8 o'clock. That is like the NDA zone that we are not allowed to publish anything from there, and everybody who has access to those servers had to sign a personal NDA with the Ministry of Justice that says that if we leak the data, we have to pay the re-election costs. Yes, so that we had to be quite careful with those things. We had like few like fail-safes there and flags that we needed to set up before any data started to flow to our DynamoDBs and forward to there. So that is something that we were pretty fast, released the data after the 8 o'clock, but that is something that we could even improve later, because now we like didn't, for example, populate the DynamoDB tables beforehand, even though we in theory could have done that, but we wanted to play it safe, so we didn't do it.
Maybe more about this S3 Lambda exporter. One of the interesting things about this, that because we have now all the data, or after the data was not updating anymore when 100% of the votes were counted, then we had the data in S3. And one of the requirements for this project was the archivability. So now we have the data as static JSON files in S3 already. And that's really good. We can just kill the API later. And it was triggered automatically when the exporter got new data. And that happened something like every 5 minutes we got new data. And then a bit about the traffic. So just like Vaalikone.fi, we went live maybe like 3 weeks before the elections or something. And during that time in the parliamentary elections, the Vaalikone.fi had something like 1.5 million unique visitors over that time, and that's pretty good. It's a new record for Sanoma. And then and you can see actually on this graph on the right, the times before something like 6 o'clock, that's the normal traffic that came to Vaalikone.fi, like when people were answering the questions. So it's basically nothing compared to when we actually started publishing the results, or actually when both Ilta-Sanomat and Helsingin Sanomat put the widgets on the front page, then that traffic started coming in, and then when we had the data available, then we of course got more requests. So the peak hour, which was around 8 o'clock, probably from 8 to 9 o'clock during that election night, we had 28 million requests during that hour. So that means something like 7,800 requests per second. And of those, only 380,000 requests went to our instances, and then so that means something like 105 requests per second to our instances. And so we had pretty good caching rate because of CloudFront, and then the API requests went to S3. And we had no production issues due to the high load. About the project, it's we had a couple of interesting learnings that we learned during the project. So one of them is about accessibility, and accessibility is hard, but it's super important. Here is a tweet from Ronja Oja, who is a blind developer and athlete. She was wondering why we recommended some weird results to her, and found out that we had mixed up the ARIA labels. So when she wanted to say, "I totally agree," she actually said, "I totally disagree," because of our fail.
Then there was this like a little incident about the S3 assets. We were talking about the whole, because we were serving the assets from our own servers first for the test environments and stuff, but we were talking about that somebody should upload them to the S3 before we go to production, and well, nobody did that, and we found out that when we were in production that then there was our assets were still being served from our application instances, which caused some problems when we did the updates, when the like old assets get deleted and new versions are only like available in our instances, and that caused some problems.
Yeah, so basically the site was broken every time we deploy something.
Yes.
Which is kind of bad.
Not optimal.
Yeah, and then kind of related to that, also we had some mix-up with cache headers when we went to production. So when we had that issue that there were some assets that were not found from S3, or from the instances actually, because we were not looking for them from the instances, and then we would send a 1-year cache header for that request, which is also kind of bad. Don't do that.
Yeah, then we had some silly things happening with our production database when we went live with the actual like the voting advice application side. We had some test data there, like test answers from when we were testing it, and we were supposed to delete those, and then we went to the database and deleted all the test answers, but accidentally also deleted all the candidates' answers from the database. But luckily we had like good backups of our databases, so yeah, we didn't lose anything, just like tiny downtime for a while. But
yeah, and thanks to Sunil for solving that problem. Yeah, and then one positive learning actually, one thing we did well was that we had our PO made us a list of like prioritizations and then names for those widgets that we had to develop in both in Finnish and in English, and description what they mean. So then we could use those English names in our code, and then when we discussed about stuff between designers and developers and product owners, we always were talking about the same things. Yeah, that was really a nice thing to do.
Yeah, that was really great, and that's something like, even if the names themselves are not like perfect and so on, but if the names are the same for everybody, then it's like makes things so much easier, and that is something that I could recommend for everybody to try to do something like that.
Yeah, and we will definitely do that in future projects at Sanoma. And you can go check it out. Vaalikone/eduskunta 2019 is the parliamentary elections, and then now if you go to vaalikone.fi, you will be redirected to Euro 2019 because it's upcoming. Thank you. So, any questions?
Really interesting stuff and well presented. It was a joy. So you considered using some kind of like previous code for it, but you pretty soon kind of scrapped the idea.
Yes. Well, there had been some like migrations happening before or after the last elections, and then the actual code base was from 2014, if I remember correctly. It was some Java Spring application with Angular front end, and we just realized that we are not able to deploy it anymore very easily, and the further development of that would be quite painful. So we decided that now it's time to rewrite that. But that was like, because like we mentioned in the beginning, that it was like three-part project. So we already had planned that we will rewrite the like the public side, like the citizen and the result service side. That was planned to be rewritten, and the candidate side we thought that we could use the previous versions, but it turned out that we couldn't. So that caused some additional stress for the time wise it was pretty strict.
So in the end, we had to just prioritize things and
Yes.
drop features.
Yeah.
I'm curious about your use of IOTS in the project, if you could talk more about that. When I saw the talk, did it give you any more confidence in terms of like runtime errors, TypeScript?
Do you have an opinion?
Well, yeah, kind of. It was a little bit like maybe unnecessary because we are also in control of all the backend APIs. So we basically could just, if something was broken, we could just fix it on the backend. But I guess it's still like the idea was nice, and I think it worked pretty well that you could check the types and then you get the actual TypeScript types out of those TS.io types. So that is something that I would probably use if I would use some third-party APIs or something that I don't have necessarily control over that easily. But
yeah, but also in our case, I think we recognized the problem faster because we could immediately see that okay, because this doesn't work because the backend response was we were expecting a string and it was a boolean or stuff like that, and then we could fix it by ourselves. But yeah. But in our case, we didn't like actually figure out what to do when it fails. We just dropped the gloves and console error did. And so I don't know actually what would be a good way of using it. How we make it? It's an Preact application that only renders one. Or do you mean the embedded?
Yeah,
embedded version. It's an iframe which embeds the tinier version of the application which just renders one component. It could have been optimized more. Now it actually includes the almost the same bundle as the actual site.
Yeah, that was due to the deadline. We didn't have that much time of optimizing the bundles and stuff, but it turned out to be working quite okay.
I don't know if you're allowed to tell about the API to the Ministry of Justice, but how was it? Was it like a nice thing to integrate, and was there like rate limitations or stuff like that? Because obviously everybody is fetching data at the same time from there.
I think it's pretty
I
good.
could comment
Okay,
briefly.
excellent.
I have the personal NDA, but I think I can comment that it's very legacy integration. There's some non-API that type of integration happening, you might guess.
Okay.
And we actually reused some of the old code for the integration part, so we didn't need to touch it too much. But practically we are like polling new data, and they are releasing it every 5 minutes. And
SFTP, right? At least it says here.
yeah, well, it's there. It's SFTP, and well, it works.
Okay. Don't touch it.
Yes.
A little bit still about load testing. Did you know the load beforehand? Like, did it match like previous year's load or previous election load, or was it a lot larger? And how did you establish confidence that you would actually be able to handle it through this scheme?
We did some load testing, but not like. But we just or inside Sanoma they have knowledge from many elections before, and they knew that they had problems before. So we knew that there, and also we can like know how much traffic we have on the both sides. So in a way,
But that was before the S3 solution,
Yes.
Yeah.
and that's why we did the S3 solution.
Yeah. Okay. So we designed this, like sat together and thought that okay, previously we have had issues with performance. How do we manage that? And then we came up with this solution.
8,000 requests per second. That's a hell of a lot.
Yeah. Many.
We were quite confident with the cloud front and the S3.
Yeah, because we had a workshop with Amazon a bit before and then we were able to ask AWS developers like, is this a good idea? And they said like, okay, it sounds like a good idea, and somebody had done this before in Sweden, and they said like the S3 can handle billions of requests per second.
So you had this immovable deadline, right?
Mm-hmm.
Were there any interesting challenges working with the client or client expectations? The team that you can talk about.
I don't know. I think everybody in the team from the client side and our side were really constructive about the deadlines. Everybody understood that it's going to be tight, and the prioritization was made really well. I think that we had those really critical components high on the priority, and then those nice to have things on the bottom. And I think it worked really well, and we managed to get almost everything developed or implemented. A couple of things we had to drop out, but the customer was still really happy.
They were super happy.
Yeah, they were about the end result. So. And
this was a really nice project because we knew who was the main PO in this case.
Yes.
It's not always that's true at Sanoma.
But yeah, good communications. We had dailies with all the stakeholders in every day and so on. So that was probably one thing that helped.
Thank you, guys.
Thank you.